Do I sound OK? Ooh, I'm really loud. OK, I'll slow down. I'm here to talk today about Dart, Flutter, and WebAssembly, a model for building web applications. First info about me, I'm a product manager at Google. I just passed 10 years. It's gone really fast. And the whole time I've been on the Dart team, so it's really been cool to watch the evolution. When I started on Dart, there was no WebAssembly. We were trying to actually ship Dart as part of the Chrome browser. Native client was a thing, and so it's amazing looking back the progress we made. I'd say actually philosophically, and we can talk after if you're curious, the days when we thought about adding Dart to the Chrome browser, I really feel like WebAssembly was kind of where we wanted to go, which is how do we do better, faster in the browser? And the fact that we have a standard thing now just makes me super excited. So you can find me, Kev Moore, on most of the things on the internet, even the blue skies and the mastodons if you're curious. And there's my weird vanity domain, which is mostly just links to all that stuff, plus talks I've given, if you want to learn more. So Dart and Flutter. How many people here are familiar with Dart and Flutter? How many have actually implemented anything with Dart and Flutter? OK, good to hear that we have some fans here. I'll do a brief introduction of both, because I'm guessing a lot of people here don't have some deep context. And then we'll talk about WebAssembly. So first, Dart, a programming language meant to be approachable, portable, and productive for apps on any platform. So here's the canonical hello world, pretty short and sweet. Last year, I went through a bunch of kind of basic language features, and I didn't want to repeat myself this year, but I think it's good to point out some things here. We're object-oriented, plus a bunch of really great functional features. The syntax is very similar to folks that use those languages listed there. We have a sound type system, which we're very happy about, including null safety, which was added in the last year when stable. So our null safety thing is not just a semantic or a syntactic sugar. It actually is sound null all the way down, which adds a lot of benefits. Happy to talk more about that. We have features in streams, records and patterns, and a very rich model for inference, which is great for running code quickly. I want to give a preview. So this is a feature we just added in the last year. Everyone's familiar with switch statements, right? You might switch over strings, or you switch over integers, or switch over enum values. This is a feature where we're switching over JSON, a map. And so look just real careful at the code. So you see the switch statement on the top line. We're switching over JSON. And now the match for the switch statement is not a string literal or an integer, an enum. It's actually a map literal. What this is saying is match any map that has the key type with a value text question. And the next four things are saying, match over a string category, a map, a string, a string. But it's not actually just matching over the values. It's saying match over the type and then capture the value. And then below, I can instantiate an object there. And so extending the notion of what we can do in Switch was something we added in the last year. It's been super productive. So we keep evolving and pushing Dart, and I think it's super useful. Another fun example of where we're using new language features. How many people have written code like this, where you kind of have a nested if block dealing with a bunch of Booleans? If you actually count all the Booleans here, there are 5. And so if you do the combinatorial math, 2 to the 5th, there's actually 32 possible cases you have to handle, right? For these 5 Booleans are active and correct and all the other things. And so this is actually tricky. Like, in this case, I've actually covered the isActive case twice. And it's tough for a static analysis to tell that you've missed a case, or you might have duplicated one or forgotten one. This is the feature in our new switch syntax, and this is actually using a feature we have called records. So you see here is I'm actually instantiating a record that's just a Boolean set of values. So positional, 5 Boolean values, instantiating this record. C#, we call this anonymous types. And then I'm switching over it. And look carefully. So what we're doing is switching over all the possible values that could exist in this record. And since all the fields are Booleans, we know all the possible values that could exist there. And actually, statically, we can guarantee that you'll hit every case. So if you don't care about the case, like you only care about is active true and is press true, you can say, I ignore those other values. But in this case, we'll actually give you static analysis that if you forget a possible value, we'll yell at you and say you've missed a case, just like if you miss a value in an enum. And if you duplicate a switch context, we'll yell at you too. So I just wanted to highlight some new features we've added in Dart that have added a lot of good ergonomics and super useful. So we keep evolving the language quickly. If you're curious about just new things we're doing in Dart, how we're pushing the language, I highly recommend watching this talk. And one feature that's actually brand new as of February is something called extension types. And so this is the ability to define a type that's basically a zero-cost wrapper. So I can say I want to make an extension type on integer in this case. And maybe if I'm doing an ID, I don't want people doing math on the ID. I don't want you adding 2 IDs together or subtracting them. I just want to care about equality. And so you have a feature that is much more ergonomic and safer than using an integer for an ID, or maybe, I'm trying to think, a string for URI, for instance, but fundamentally cheaper than doing a wrapper value. And actually, we use this in interop that I'll talk a little bit later. So that's just some stuff about Dart. We don't just use it for Flutter. Our common front end for all of our languages is written in Dart, along with our analyzer and our formatter, so thousands of lines of code. Both of our JavaScript compilers and the Wasm compiler are also written in Dart. Our package site, which I think at max handles 200 QPS, I think more now, is completely in Dart. And you can compile Dart code, AOT, to a really tiny binary and have a single binary to deploy, which is actually great for containers. You can actually have a 10 megabyte container and do millisecond cold starts on containers in Dart. So this was actually tweeted yesterday. I'm like, I'm going to totally steal this tweet and publish it. Usually when you think of Dart, you think of Flutter, but we used a bunch of places. I think there's at least 3 production companies now basing on offering server offerings in Dart, which again is a small number of total Dart users. Most of our users are Flutter, but it's exciting to see people using it in other places. So if you want to go try out Dart, dart.dev, and dartpad.dev, if you want to hack some code together now, you can do that right now. It runs online. So let's jump to Flutter. This is by far the most popular framework for writing, or the most popular usage of Dart, a framework for building apps, beautiful, fast, productive, open on any screen. So flutter.dev is the URI. This is actually a really great slide for me to do, because I was looking at my slides from last year, and last year I said 700,000, and we've topped over 1 million. I think we're actually closer to 1.2 million. I don't have the exact number, but the number of apps we have in stores is substantial. The percentage of new apps on the Apple iStore or the App Store, I don't think I'm allowed to see the actual number. It is really surprising. There are a lot of new apps. I'm sure most of you with a mobile device have a Flutter app on your phone, and you just don't know it. We're used all over. And over 30 teams at Google use Flutter. So not YouTube itself, but there's a YouTube Create app out in beta. Uses Flutter, Google Earth, Classroom, a bunch of things. Family Link, which I use all the time with my kids. Pieces of the Cloud offering on mobile devices, all use Flutter. And usually you think about doing 3 bullets. We're crazy and do 5 in terms of kind of the things we're happy about. Beautiful, fast, productive, portable, open, all open source. I want to talk about 2 of these today, which is portable and fast. First, portable, being able to run anywhere. So most people that have done Flutter, where we started out, was mobile apps, Android and iOS. So not just ARM, but actually we now have support for RISC processors, which we're excited about. Obviously deploying to web with JavaScript. Today I'll talk about WebAssembly. You can build desktop apps, Windows, Linux, Mac, and even embedded scenarios. I still don't have the tweet from last year. Someone has actually written and running Flutter on a lanyard, which is kind of crazy. Toyota uses us for infotainment systems in cars. We run everywhere. My favorite example, and actually this is something that I knew about last year and couldn't talk about, but this released in October. Google Earth recently ported all of their common UI to Flutter. I'm going to be very careful there. So obviously Google Earth has a 3D rendering engine that was written in C++. But the problem was they had this common code they could use across all the mobile devices and the web with WebAssembly. But all the common UI, the widgets you see on the left and the right here, they had to rewrite in 3 times in 3 different platforms. And of course, this is tough for a team. You have to maintain it, stay consistent. And they were able to substantially reduce the amount of code they had, greatly increase their velocity, because now all this common UI, you see the buttons on the bottom and the side panels, it's all written in Flutter. So this is a great example of Flutter Web. And actually, so if you have Google Earth on your phone, or you go to earth.google.com, you're running a C++ app with Chrome written all in Flutter. So besides portability, fast is important. We want something close to native speed. And I highlighted this app last year, Wondrous. We built this as an example of being able to have high-fidelity apps that run on iOS, frankly, and Android. But this year, I thought I'd actually show you. So here's the Wondrous application running on my desktop. I'm doing a swipe gesture. Oops, wrong swipe gesture. 2 fingers. There we go. So I can swipe between these famous places in the world. You can see the pretty animations, even the little flipping around here. Integrations with things like YouTube and Google Maps. So this is all written in Flutter and running on desktop. Although actually, it is not a desktop app. And I did the same thing last year, and I still think it's funny. This is actually a web app. So the ability to have a super high fidelity, beautiful user experience, the kind of customization that you would really want, something that looks really good native, and be able to deploy to web, that's what we do with Flutter. And we're super excited about it. Of course, now my presentation's messed up. Let's see if we can get it going. So I invite you to go now, although if you go on a mobile device on the web, you might notice that the performance is not spectacular. It's actually pretty solid for a JS thing. But we want to have this kind of rich experience be really beautiful and fast and feel native even on mobile web. And so how do we do that? Well, actually, before we get into that, though, I'm going to say if you want to try out Flutter as well, Dart.dev also has Flutter content. And so this is an example of a 2D game engine called Flame that's available. So if you want to try out what our Cupertino widgets are, if you ever want to see the date time picker in a web browser on a Linux laptop, you can do it on Dartpad. So if you want to play with Dart and Flutter, Dartpad's the place to go. But I want to talk about web specifically. First, a slight aside about sites versus apps. And this is actually really important in terms of how we think about what's important and how we target things with Flutter Web. I won't read through all of these, but if you Google the term bimodal distribution, I think there actually kind of is two islands here that matter. And certainly you can switch between the two, but I think there is this notion of kind of a traditional notion of what we think a site is. Like I think about Wikipedia, which is text-based, more linear, more static, not so much user content or user state, right? Maybe not so much code. And then on the app side, often much more than text. It's interactive, you write lots of code to maintain it, you have user state. So I think there is kind of like two clusterings of experiences on the web here. And I'd say, most content on the web is still sites. But being able to deploy a rich application experience is super valuable on the web, and that's where we're really focused. And so certainly when you think about sites, you want it to load really fast, you want it to be indexable, you want the broadest reach possible. And on apps, it's really about having flexibility, the type of experience you can offer, the richness of the experience, and maybe portability, the ability to actually deploy it natively on desktop or web, or desktop or mobile. And so obviously HTML and CSS, JavaScript work great on the site side. And what I'm excited about, especially on the Flutter team, and we're seeing this with other technologies as well, is thinking about a new paradigm for experiences that are based on accelerated graphics. So this is using Canvas, WebGL, and hopefully in the future WebGPU and WebAssembly. And Flutter Web specifically is for applications. So when you think of sites, the examples I'll bring up, not surprising, are our sites. So if you go to dart.dev or flutter.dev or a package site pub.dev, these are unapologetically HTML and CSS and JavaScript. I think in some cases we actually source some of the JavaScript in Dart, so we compile the Dart to JavaScript. But they're DOM sites, they're HTML sites, and that's perfect for this scenario. This is documentation, this is a search engine. But when you think about rich experiences, so I showed you Wondrous, the developer tools that we have for Flutter are all running in Flutter Web. We have companies that are betting on us. So Superlist is an amazing to-do app, collaborative to-do app. Rive, as actually mentioned earlier, does an amazing, has a whole 2D vector animation experience that runs completely on the web. You can install natively as well. And things like Google Earth. These are apps. So we don't care necessarily as much about indexing these. Maybe your homepage you want indexable, but I don't want my bank content indexed, right, necessarily. And so, and maybe it's okay if you have a splash screen and a little bit of load time because you have a rich experience and you're going to spend minutes or hours in the experience. And so this is kind of the place for targeting. And let's see how we make that better with WebAssembly. So today, when we talk about Google Earth and some of the other apps we talked about, we're compiling to JavaScript. So we do have a low-level library called Skia, and this is actually, we're in the process of migrating some of this right now to a new technology called Impeller. But at least on the web right now, we're using a technology called Skia. This is actually the 2D rendering engine that exists in Chrome, if you're curious. We compile that to WebAssembly. And then we take all of the engine code, the framework code for Flutter, so you think animations, all of our layout, all of our widgets, all those things, that's all sourced in Dart, along with your application code or packages that you use. And that now is all compiled to JavaScript. And what we're excited about is moving to a world where that's WebAssembly. So we still have the CanvasKit bits. In this case, we call it Squasm. This is what happens when engineers name things. That's OK. And that's linear memory Wasm. And as we discussed last year, and I think Thomas and Tom from the Chrome team will talk tomorrow, the GC stuff is where we're targeting Dart. And we're excited that as of, I believe it was November, both Firefox and Chrome have stable support for GC. So why would we do WebAssembly? Implementing an entire compiler is not easy, and we did all this work for JavaScript. So why did we do it? performance. And in some cases, correctness. We'll get to that later. But first, performance. So this is actually off our performance dashboard. We're running the same app. I think it's a material demo we had. We still have an HTML renderer, which you would like to get rid of, because there's a bunch of reasons for that. But I'm comparing performance here. So there's the HTML renderer we have, legacy, our current JS implementation, and then WebAssembly. And as you see here, we're over twice as fast for initial load. The unit of time is microseconds, so we're talking about 100 versus 50 milliseconds. So not only is it definitively better, and this is across multiple releases of, or multiple builds, multiple commits, effectively, of Flutter. Notice the noise as well. So obviously, if you scale that up, all the little bumps will get bigger. But the bumps are much higher in the JS version. And obviously, performance benchmarks, there's always a little bit of noise. So not only is WebAssembly faster, it's consistently faster. It's reliably faster. You don't have as much bumps in the performance. And in fact, you can see this. I took the Wondrous app I showed you earlier. I made a custom build that actually deployed to WebAssembly. Someone on our team made this little benchmark button. We actually ran through about 10 seconds of flipping between screens, scrolling, doing all the transitions. So about 1,000 frames we captured. And then we looked at the analysis. So as you see here, so P50, P80, you guys know what I'm talking about when I say this? The 50th percentile. So the median frame time is about 60% faster with WebAssembly. And what's really exciting is when you get to P90, P95. Talking about 110%, 120% faster. So obviously, if you're trying to target 60 FPS, 15, 16 milliseconds is your goal, right? Like that's how you don't jank when you're rendering frames. Obviously, on my M1 Mac, 8 milliseconds is fine. You start talking about mobile devices, the difference between 15 milliseconds and 30 is the difference between janking and not janking. And so you have so much more overhead on the WebAssembly version. And what this means is either you can do more on the app, more interesting animations, more interesting effects, richer content with the exact same behavior, or you can go much lower on your devices you target and still have a great user experience. We've done some of the benchmarking with this Wondrous app on a 6-year-old Chrome device, a Samsung device. And it was amazing, the difference. It's night and day what you can see with WebAssembly. So one trick we do is obviously just WebAssembly's faster. And the second thing is, and this is one of the benefits of using canvas-based graphics, accelerated graphics, is actually we can do off-thread rendering, which is kind of crazy to think about doing on the web. So this is a zoom in. It's kind of hard to parse. I apologize. But you can see the main thread and then the worker thread. And it's not all of the work, but a huge chunk of work we're actually able to do off-thread. And of course, anyone who's done any UI programming, especially on the web, a lot of things end up happening on that main thread. And that means you're blocking UI, you're janking. And so the ability to actually offload rasterization to a separate thread means you just have a much more interactive, much more smooth user experience. And this is the benefit of using hardware-accelerated graphics on the web and WebAssembly. The second thing we want to talk about is correctness. So here's a quiz. A or B, which column is correct for this high-bit math? I'll take a shot out. And you don't need your phone. B is correct. What's the fast way to figure out that B is correct? Less zeros. It turns out when you do the powers of 2, you should not have trailing zeros. They should all end in 2, 4, 8, 6, 2, 4, 8, 6 forever. So why column A? Why are there zeros? Any guesses? No 64-bit integers in JavaScript. So JavaScript doesn't have the notion of an integer. It's just JavaScript number. And so it's effectively a double. And the problem is, after about 53 bits, you start getting rounding errors. It goes to double math. And so obviously, we're able to correct for this, right? So if you're doing cryptography, I should be very clear, maybe crypto too if you're doing Bitcoin, you have to do a bunch of special tricks on the browser to make sure that you have correct numbers. You can't go beyond 32 bits, basically, which is really unfortunate. And so we tell folks in Dart that the number precision is a factor of the runtime, but actually being able to have reliable numbers. So I actually have verified that on the Dart VM and on Wasm, the powers work all the way through. And of course, 2 to the 63rd goes negative for weird reasons, so I cut that one off. But actually, Wasm's correct, which is great. So actually, we're in place now. We had a number of places in our tooling, even in the last few months, that were just doing math, like comparing 1.0 to 1, and if they're the same or not, to figure out if we're on the web. We can't do that anymore, because on the web might be Wasm, and so numbers are correct now, which is super nice. So how do you take, as a user of Flutter, how do you start using WebAssembly? It must be really difficult. Actually, it's super easy, barely an inconvenience. You just add the flag. So as of today, or yesterday, we now have beta out with Flutter. So Flutter beta now has the ability to build with Wasm. And it's that simple as as an author. If you don't do any interop. So if you're using all the widgets and things, they just work and compile the Wasm. And other than perf, they should be basically identical implementation, assuming you're not doing high-bit math. And actually what we do now, by default, there's actually no way currently to deploy only Wasm. So if you pass the Wasm flag, we will compile both. So we will run both our JavaScript compiler and our WebAssembly compiler with every build. And we do the work to do runtime feature detection to switch between the two. So you can do one build and deploy, and on browsers that support Wasm GC, you'll get great performance. And actually, even the JavaScript version, generally you get pretty good performance. It works well. You can turn it up to 11. And so the idea here is there's no cliff. You can support all browsers today. Browsers that have support for GC and the features we use will be faster. And then my aspiration for this calendar year, we'll see if it happens, I'm a product manager, not an engineer, is I'd like to get to the point where, by default, if you build for web, we will always build WebAssembly. There's some things we're working on. And in fact, if you're really curious, I'll show some examples here in a bit. You can dig in and look at the MJS file, which is how we bootstrap things. And you actually can see a numbered list of every function that we import into the Wasm module. And this is kind of how we bridge the browser stuff. So if you're curious how we do talking to browser APIs, you actually see it in the generated MJS file. So there's two examples you can look at today. I showed the material demo last year, so it's the same URI, and you could open it now in Safari or Firefox and Chrome. And if you look at the dev tools, you can see which version you're using. Keep in mind that they both load a Wasm module, which is this canvas kit Wasm thing. So you want to look for main.dart.js versus main.dart.wasm. But in Chrome, at least, you can look at the Wasm, you can expand it out. It shows the Wasm text format. You can set breakpoints if you want. It's all there. This vote thing is actually the first thing I ever wrote in Dart. If you're interested about election methods and ranked voting, we can talk later. It's an interest of mine. But I was very excited to get that up and running, and it's a more simple app, written and deployed with WebAssembly. Of course, there's one detail left, which is how do you handle JavaScript, right, in this new Wasm world. Before, when you only cared about JavaScript, a bool in Dart effectively was compiled and used as a boolean in JavaScript. The exact same thing. So really no conversion was necessary. But now we live in a world where a Dart bool compiled to WebAssembly is not the same thing as a JavaScript boolean, right? It's actually a Wasm I32. We use 0 and 1. Not surprising. It's a good thing to use. So now we need a mechanism to talk to browser libraries, other JavaScript libraries correctly, and have it work the same in JavaScript and WebAssembly. So there were 4 things I wanted. I wanted it to be sound, meaning like from a computer science perspective, we don't mess up typing. Consistent, you want the JavaScript version and the WebAssembly version to work the same. You want it to be fast. And I would have loved it to be magically trivial. You just do the right thing and we'll convert for you. It turns out that's really hard to do and do fast and do consistently. So we punted on magically trivial. There's some work you have to do. Although what's interesting is we now no longer kind of gloss over the difference. So like JavaScript is a different beast than Dart. And especially now that we're in WebAssembly, we don't assume that. So we actually expose an entire hierarchy of objects that represent things from JavaScript, big int, symbol, numbers, even things like promises. So that in Dart, there's a notion of a future. In JavaScript, it's a promise. And we expose a hierarchy here, and then mapping between it. And so what's cool is you have to do the work to call to JS to Dart to pass things around. You need to convert a Dart function to a JS function. You pass things. And effectively in Dart to JS, it's mostly a no-op. In some cases, there are differences. But for things like Boolean and string, we just pass it over. All these operations are no-ops. Then obviously, on the Wasm side, we need to convert. Like we need to convert the notion of a JavaScript number to the right kind of number as well on the Dart side, right? Like, do you want us to treat it like an integer or a double? And you need to tell us, because at runtime, it's just a JS num. And that could be, it's effectively a floating point. So we have an explicit notion of conversions. This is well documented. If you're curious, go take a look. And today, we're super excited to say that we're now in beta. So last year, a year ago, I was here talking about this as an experiment. We are in the process now of flying towards stable. Stay tuned. The website I have here, flutter.dev/wasm. We'll have all the details. As of today, it's beta, and obviously if you're watching this recording in the future, you want to look at that website for what the current story is. As far as browser support, so Chromium-based browsers, so obviously Chrome and Edge, things are fully supported. I mentioned before we have this cross-thread rendering. It turns out that Firefox has what we consider a bug, which is they do extra copying when we're copying bitmaps across the web worker boundary, and it's insanely slow. And so we need to figure out, are we going to basically turn off the cross-thread rendering and just use a single-thread rendering on Firefox? Or hopefully, Firefox will fix their bug, so we need to figure that out. I'd recommend if you go to either of these bugs, please don't spam with me too, but the +1, whatever star thing is, they know these are important bugs, they appreciate that. Same thing with Safari, and actually it was great to see the Kotlin talk. It seems like WebKit is much further along than I thought. They're cranking along really well. But obviously once we're stable in Safari with GC, we'll be excited to see Flutter on Wasm running in Safari as well. So I hear this a lot, and I see this in discussions, right? Like people are like, I want a WebAssembly UI framework. Like, give me a WebAssembly UI framework. I have one for you. It's high performance. It's a rich UI framework that covers material design and Cupertino, which we call like iOS's design language. So if you want to make an app that looks like a native iOS app or native Mac app, you can do that in Flutter today. Full support for localization, internationalization, accessibility. It's battle-tested in production by Fortune 100 companies in the States, all over the world, a bunch of Google products. And as a bonus from this, this beta framework for WebAssembly, it's also stable in JavaScript and lets you deploy natively to iOS, Android, and desktop. So I think it's a pretty good solution if you're interested in doing a WebAssembly UI framework. And we'd love to have you. So flutter.dev, dart.dev, the updates on where we are with Wasm is flutter.dev/wasm. And of course, if you're going to find any of my other random things I've done, go to my personal website, and I'm open for questions. Thank you much.
So, might be a naive question, but like the performance is all great. In terms of power management for mobile devices, are the implications the same in terms of like sleep states and stuff when running WebAssembly applications? I'm thinking things like progressive web apps and like background threads and all the rest of it. Or are they higher performance, but there's still work to be done in terms of efficiency, etc.? I don't know whether that is. I hope it makes sense.
So it's. In some ways, Flutter web apps are just other web apps, right? So if you're thinking about doing background processing, obviously we have our background fed we're using for rendering here in the Wasm case. If you're doing other background processing or whatever, it's just like any other web app. So if folks install a web worker or do a PWA and they register for background events, I can't speak to the details of managing performance or expectation of that, but it's just like any other web app. We are no different in that respect.
But the WebAssembly version specifically, versus the JavaScript version.
Yeah, for the same code, I mean, it's kind of what we talked about, right? So like, fundamentally, we're getting the same pixels on the screen. It's actually kind of crazy to go through all this work implementing an entire new language, target, and all the tests, and then we have the same. And we have our screenshot tests, and they're the same pixels. Like our goal is pixel identical, and so what you get is like half the CPU time. So you're doing the same work, but you're spending half the CPU. And even doing multi-thread or multi-core, you get obviously benefits there in terms of jank and everything else. But in terms of the total amount of CPU work happening, it's half. And so you're either getting more frames on the screen, drawing frames faster, obviously, or you're just using less battery, which is great.
Sweet. Thank you.
Going once?
I'm curious if you're using WebGL for rendering the UI. How do you achieve accessibility there? Do you have to define specific accessibility attributes on all of the UI elements separately? And how much overhead does that bring to the final binary size? As far as I understand, you would have to re-implement some of the things that are already available in the browsers for DOM if you did not use WebGL in the first place.
Right. So for accessibility, we actually use the DOM. And so there's certain signals you get from the system to realize that the user wants to use accessibility, and then we hydrate a hidden DOM underneath the canvas, effectively, that has all of the DOM elements you care about, and has the right ARIA tags and everything else. There is a runtime perf hit there, and probably a compile time hit, because we have a bunch of logic there to instantiate the tree. The nice thing is because we're not worried about the presentation to the user, but just the accessibility elements, it's relatively lightweight, especially compared to doing a full UI framework in HTML. But there is obviously compile time hit to include accessibility, just like on any platform, and we're all happy to do that work because it's good to have an accessible application. And there's a runtime hit because now if you're scrolling or interacting with the app, not only are you manipulating the pixels on the screen, you're also manipulating this DOM, this kind of virtual hidden DOM, to present accessibility. But generally, we find it OK. Like, we get bugs on the accessibility side for just correctness things that we're fixing very quickly. But in terms of actual end users using accessibility of the Flutter app, I've actually never gotten a bug about performance. So it seems to be solid.
Thanks.
It is a gnarly problem doing a Canvas app and having accessibility. It's tricky. Anybody else? Thank you so much.